Welcome, my friends. I'm so excited because in this video we get to talk about the two sample confidence intervals. That is the confidence intervals to compare two means and two proportions. So let's go ahead and get started. Let's first talk about the confidence interval used to compare two means, which is called the confidence interval for the difference in means. For this confidence interval, we want to estimate how much larger or smaller one mean is from one population to another mean. For example, we might want to compare the weekly screen time use for individuals in Gen Z versus millennials. Since we have two population means, we will use subscripts so that we can identify them. So mu1 might represent the population mean for Gen Z, and mu2 might represent the population mean for millennials. The purpose of the confidence interval is to estimate the difference in population means, or mu1 minus mu2. For this example, this quantity represents how many more hours individuals in Gen Z spend on screens per week compared to millennials on average. Or if the result of the confidence interval contained negative numbers, that would represent less time for Gen Z compared to millennials. In general, positive values in your confidence interval will indicate a higher mean at your first population, and negative values will indicate a higher mean at the second population. Here's an example of a possible 95% confidence interval. Maybe your confidence interval ranges from 5 to 15. Remember that the values in the confidence interval are going to represent our estimate for the difference in means. So this confidence interval would mean that we are 95% sure that Gen Z spends anywhere from 5 to 15 more hours per week, because we have positive numbers, on average on screens than millennials. Now, what if you had negative values in your confidence interval? Well, then you would just switch the word more to less. So then that would mean that we are 95% sure that Gen Z spends anywhere from 5 to 10 less hours per week on average on screens than millennials. Here is the formula for the confidence interval for the difference of means. It's a little bit complicated, so due to the calculation-intensive nature of this formula, we're going to be using a TI-84 function called toSampleTint to calculate the confidence interval for us. We can still visualize the confidence interval on a number line. At the center of our confidence interval will be the difference in sample means. This is what we call our point estimate. The goal is to estimate the difference in population means, mu1 minus mu2. But of course, since these are population means, we would need to have a census of all individuals in each population in order to know this value exactly. Instead, we're going to settle for just a sample. But since we know our sample is probably off by a little bit, we're going to add and subtract some margin of error to get to our upper and lower bound. In the end, we will say that we are some percent confident, let's say 95% confident, that the difference in means falls between our lower and upper bound. Now, to interpret two sample confidence intervals, I use a slightly different template than I used for the one sample case. Here's the template that I use. I say that we are C% confident that the first population mean, or first population proportion, if you're dealing with proportions, is anywhere from your lower bound to your upper bound larger than your second population mean or second population proportion. Once you have constructed your confidence interval, you will need to interpret your confidence interval, which really just means explain what the confidence interval means in the context of your question. I use a different interpretation for two sample confidence intervals than I use for one sample confidence intervals. And here's the template. We state that we are C% confident, where C is your confidence level, that the first population mean, or first population proportion, whichever you're dealing with, is anywhere from your lower bound to your upper bound, either larger or smaller than your second population mean or second population proportion. Now, I know there's kind of a lot of things going on here, so let me try to explain a little bit. First of all, you should always write your lower and upper bounds as positive numbers, even if they were negative. And that's because you're going to be using either the word larger or smaller to kind of take care of the negative. So if you had negative values here, using the word smaller kind of switches things around to take care of the negative, right? Because remember, we said that if we had negative values here, that's representing that the first mean is actually smaller than the second mean. Also note that if you had mixed signs, as in your lower bound might be negative and your upper bound might be positive, you might have to use the words larger and smaller twice, as in you might have to use the word smaller next to the lower bound and maybe larger next to the upper bound. Also, make sure that you are describing the population mean or proportion as it relates to your specific problem. Let's take a look at an example. Let's say this is our 90% confidence interval, which ranges from 5 to 15 for the difference in the mean weekly screen time for Gen Z and millennials. Our interpretation would be we are C% confident, in this case 90% confident, that in this case we're dealing with population means, so we would say the population mean screen time for our first population, which is Gen Z, is anywhere from our lower bound, which is 5, all the way up to our upper bound of 15 hours, larger because we had positive numbers than the population mean screen time for millennials. And as I mentioned a second ago, you should use smaller for negative values. So if these values were negative, then you would use the word smaller here rather than larger. Let's take a look at the assumptions that need to be met in order to calculate this confidence interval. The first assumption is that we must have random samples from two independent populations. That just means that we have two completely separate independent groups that we are comparing, like Gen Z and millennials. You must either have a sample size of at least 30 for each of your samples, or each of your distributions should be normal for your two populations. Third, the populations are not assumed to have equal variances. This is what is called the unpooled method. Let's take a look at an example. A sample of 45 Gen Zers revealed the mean weekly screen time of 25 hours with a standard deviation of 3 hours. A sample of 57 millennials revealed a mean weekly screen time of 18 hours with a standard deviation of 2 hours. We are asked to construct a 95% confidence interval for the difference in population means. So our first sample is going to be Gen Z, and our second sample is going to be millennials. For the Gen Zers, we had a sample size of 45, or N1 equals 45. The mean was 25 hours, or X bar 1 equals 25. The standard deviation was 3 hours, so S1 is equal to 3. As for millennials, we had a sample of size 57, so N2 is equal to 57. The mean is 18 hours, so X bar 2 is equal to 18. The standard deviation is 2 hours, so S2 is equal to 2. We are asked to find a 95% confidence interval. To calculate this interval, we're going to use the TI-84 calculator. So go to Stat, arrow twice to Tests, and then scroll down until you see an option which is called ToSample T-int. Make sure not to choose the option that says ToSample T-test. That's for a hypothesis test. We are doing a confidence interval, so we should choose option 0, which is ToSample T-int. You can either select data or stats. If you had data, you would have plugged it into your lists, but in this case we have stats. So we can plug in the stats. We have X bar 1, which is 25, S1, which is 3, N1, which is 45, X bar 2, which is 18, S2, which is 2, and N2, which is 57. We're going to use a confidence level, in this case, of 95%. So we can put in 0.95. This must be put in as a decimal. And we are always going to choose no for pooled. There are two different versions of the test. One does not assume equal standard deviations, and the other one does. And if we choose no, that means we are not assuming that we have equal population standard deviations for these two populations. So always choose no. It's a little bit more conservative to choose that option, and that's the one that we're always going to do in this class. And if you press enter, you will get the result here, and the confidence interval is the very first output. Here's the lower bound, 5.9641, and the upper bound is 8.0359. So here I am showing some of the steps, as well as the output, which is the same output that we are seeing here. The last thing we need to do is interpret the confidence interval by writing a conclusion statement. To write the conclusion, I'm going to use the template that I provided in a previous slide, which I have right here. So we should be stating that we are C% confident that, in this case, the population mean number 1, which is going to refer to the Gen Zers, is anywhere from our lower bound to upper bound, either larger or smaller than our second population mean, which will relate to the millennials. So this is what I came up with. We are 95% confident, since our confidence level is 95%, that the first population mean, which in this case is the population mean screen time for Gen Z, is anywhere from our lower bound, which is 5.9641, to our upper bound, which is 8.0359, larger than, since they're positive numbers, the population mean screen time for millennials, which is population mean number 2. All right, here's a problem for you to try. Martin the Master Farmer has planted strawberries in 2 rows, each 10 square feet wide. The first row is fertilized with the experimental super strawberry solution, and the second row is treated with a basic fertilizer. The number of strawberries per square meter is recorded and shown below in the table. We are asked to construct a 90% confidence interval for the difference in strawberry yield for the 2 fertilizer types. So the difference between this problem and the last problem is, in the last problem, we were given these statistics, like the sample size, the x-bars, and the s's, but in this one, we are given the data instead. So what we can do is we can still go into our test here and choose that option 0 for 2SAMP t-tests. To get here, I did stat and then arrow twice to the right, and this is option 0. We can still go in here, but in this case, we're going to have to put in data. So we're going to have to scroll over here to data, and you're going to have plugged the numbers into your list 1 and list 2. So the first thing you should do is go to stat, and then edit, and then clear out your lists if there are numbers there, and plug in all of these numbers. And then once you're back in here and you have all those numbers there, it's going to pull those values from your 2 lists to calculate the confidence interval. Okay, so I'll let you give that a shot, and then we'll move on to the 2-sample proportion interval. All right, so let's talk about the confidence interval for the difference in 2 proportions, which is going to be very similar to the confidence interval we just did. So for this confidence interval, we want to estimate how much larger or smaller one proportion or percentage is compared to another. So the example I'm going to use is, maybe we want to compare the percentage of vegetarians in the United States to India. So we might represent P1 as the percentage of vegetarians in the United States, and P2 might represent the percentage of vegetarians in India. We are trying to estimate the difference in population proportions, which is going to represent how much higher or lower the percentage of vegetarians is in the United States compared to India. Here's one example of a possible 95% confidence interval, which might range from 0.02 to 0.06. This would mean that we are 95% sure that the United States has anywhere from 2% to 6% more vegetarians than India. Since we have positive numbers, we use the word more to represent that the first population is seeming to be larger than the second in terms of this proportion. If we had negative numbers, on the other hand, then we would say the opposite. We would say that we are 95% sure that the United States has anywhere between 3% to 8% less vegetarians than India, because we had negative numbers. If we were to calculate this confidence interval by hand, we would be using this formula, which is admittedly a little bit complicated. Due to the calculation-intensive nature of this formula, we're going to be using a TI-84 function called 2propzint to calculate the confidence interval for us. Let's visualize the confidence interval on the number line. We are trying to estimate the difference in 2 population proportions, but of course we would have to have a census to know the population proportions exactly. So instead, we most likely have a sample, and we can calculate the sample proportions, p-hat1 and p-hat2. The point estimate for the difference in population proportions will be the difference in sample proportions, which will be at the center of our confidence interval. We can add and subtract our error, which is the part after the plus or minus, to get to the lower bound and upper bound of our confidence interval. Here are the assumptions of the 2-sample proportion confidence interval. Number 1, random samples must be taken from 2 independent populations. Number 2, each of these 4 quantities should be all at least 5. This ensures that the distribution of the difference in sample proportions will be approximately normal based on the central limit theorem. This is required in order to use the z distribution, which is part of the formula. Let's look at a complete example. A sample of 220 Americans revealed that 11 were vegetarian, and a sample of 250 Indians, that is, people who live in India, revealed that 75 were vegetarian. Construct a 99% confidence interval for the difference in the proportion of vegetarians between the 2 countries. Sample number 1 represents the Americans, and sample number 2 represents the Indians. From sample number 1, we had a sample size of 220 and a number of successes of 11. We had 11 vegetarians. From sample number 2, we had an N2, or sample size number 2, of 250 and a number of successes, or x2, of 75, 75 vegetarians. At this point, we are ready to go to the calculator. On the calculator, press the Stat key, arrow twice to the right so that you're on the test menu, and then scroll down past the option that says 2prop z-test, and all the way down to the option that says 2prop z-int. A lot of people might mistakenly choose option 6, the 2prop z-test, but the one that we need is the 2prop z-int for 2 proportion z-interval, or confidence interval. Choose this option, and then fill in the appropriate values. x1 is 11, n1 is 220, x2 is 75, and n2 is 250. The confidence level in this case is 99%. Go ahead and calculate, and we will have our answer. Here is the same output in the slides. Now the only thing we have left to do is interpret this confidence interval. Here's the general interpretation for a confidence interval for 2 samples. Modifying this for this specific problem, we would say that we are 99% confident that in this case population proportion number 1, which is the proportion of vegetarians in America, is anywhere from, and then now this is a little bit where the interpretation breaks down, because it does say lower bound first and then upper bound second, but technically you probably want to write your smaller number first in absolute value terms. So this is where you might kind of mix these two up. So I'm going to write my lower bound first, which is 16, I guess it's really my upper bound, 16.63% to 33.37%, smaller since we have negative numbers than the population proportion of vegetarians in India. And that completes our problem. All right, here's a problem for you to try. A sample of 115 GRCC students revealed that 89 have a job, and a sample of 140 Grand Valley students revealed that 100 have a job. Find a 95% confidence interval for the difference in the proportion of students who have a job at the 2 schools. So go ahead and write down your x1 and n1 for each of your 2 samples. Go to your calculator and run the 2prop z-int procedure. And then once you get your confidence interval, write a conclusion or interpretation statement. All right, I think that's all I had to talk about in this video, so hopefully you found it useful, and I will see you in the next video.